Hello, Dr. Bill here. Today we're going to take a look at similar triangles. And this lesson was requested by two of my students, Gabriella and Joey. So here I want to review similar triangles for you and for all those who could benefit from it. These do come up quite a bit on the various standardized tests. So let's take a look at this. So we have here actually two similar triangles. Similar triangles are triangles that have corresponding angles that are equal, but sides that are proportional. So let's take a look at this. We have first the small triangle, which is KLM, and then the larger triangle, the similar triangle to that is KNO, right? And let's first see the question, then see how they're similar and what we need to do here, right? So we say here, first of all, we note that the figure's not drawn to scale, which means we can't rely on the drawing. And that makes sense. If this left side has a distance of 2, the right side a distance of 5, clearly that does not look, proportional. So anyway, the question is, what is the length of LM in the triangle above? And LM is obviously this segment. So let's again see what we have. All right, in the small triangle KLM, this angle K obviously corresponds to KNO, right? This angle K, because it's the same angle, right? So that obviously corresponds in both the small and the large, right? Okay, now since here we see that all these distances are the same, 2, 5, 2, 5, etc., all the way down, it means that all of these lines are parallel, right? And if LM and NO are parallel, it means that here angle KLM, right, is congruent to angle KNO. So there we go. These are equal angles, right? And then again, for the same reason, angle KML is going to equal or be congruent to angle KON, right? So let's mark these as well, right? So we know they're equal. Okay, now what we can do is we can set up sort of a proportion for our small and big triangles, right? So let's see what we have here, right? We're going to do small triangle and big triangle. Okay, now let's look at the corresponding sides, right? For the small, we have here, this side is going to be 4. We have 2 and 2. So that side is 4. And the corresponding side for the big triangle is 2, 4, 6, 8, 10. So that is 10, right? Then for the other side, we have here for the small 5 and 10. So we can say that is 10. And then for the big, 1, 2, 3, 4, 5 times 5 is 25. And then for the base here, obviously for the big, it is 40. And for the small, we don't know. That's what we're trying to find, right? Okay, now, since in similar triangles, the corresponding sides are proportional, right? It would mean that the multiplier here will be the same for all 3 triangles, all 3 sides rather. In other words, right? So 4 times a number is 10. 10 times that same number is 25. And then this number, which we will call x, times that same multiple will give us 40, right? Okay, we may be able to see right away that our multiple is going to be 2.5 because 10 is a pretty easy number to work with. So 10 times 2.5 is going to be 25, right? Same thing, 4 times 2.5 is 10. So here our multiple is 2.5. okay? And again, to do that, we could simply divide, if we wanted to prove it, divide 25 by 10. Okay, here we go. We put our decimal. And then 10 goes into 25 two times, right? With 5 left over. And then 10 goes into 50 5 times. So again, our multiple is 2.5. So this means that 2.5 times x is going to be 40. And then we would simply solve for x by dividing by 2.5. Those cancel, right? And now our x, which is our side LM, is going to be 40 divided by 2.5. So let's do that here. We have a little more room, okay? So we've got 40 divided by 2.5. Again, we would want to move that over 1. So it's the same as 25 into 400. Okay? All right. Now, once again, if you want a long division review, I have a great video on how to take shortcuts with that, but here it is again, right? Okay. So 25 is going to go into 40 one time, right? There would be 15 left over because 1 times 25 is 25. 40 minus 25 is 15. So that would be 15 here. So 25 would go into 150 6 times. Okay. And then obviously 25 times 16 is 400. Okay. All right. Now our answer then would be 16. So there we are, right? Okay. I hope you found this little lesson on similar triangles to be helpful. If you did, please do subscribe to my channel. Hit the like icon, the bell as well to be alerted of all future videos. Please share with anyone who you think could benefit from this lesson. Thank you very much. This is Dr. Bill, and we will see you on the next video.